In this video, we are going to explore the second and third groups in the electromagnetic spectrum, which are microwaves and infrared radiation, and because they are located towards the far left side of the spectrum, this means they both have relatively long wavelengths and low frequencies compared to the other types of electromagnetic waves. Starting with microwaves, we can broadly classify them into two main categories, depending on how they interact with water molecules in their path. The first group of microwaves are those that are not absorbed by water molecules and are mostly used for communication via satellites. Since satellites orbit high above the Earth, any microwave signals intended for them must be able to pass through the Earth's atmosphere, and if the waves were absorbed by water in the atmosphere, they would not make it through successfully. This is important because the atmosphere contains a significant amount of water vapor which could potentially absorb and block the signal. However, the microwaves used for satellite communication have the correct properties to pass through without being absorbed. Once they travel through the atmosphere, they are received by the satellite, which processes the signal and transmits it back down to Earth, where it is received by a satellite dish, allowing us to access services like satellite television and global communication. The second category of microwaves are specifically absorbed by water molecules and are therefore used in microwave ovens to heat food. Since most of the food we consume contains a large percentage of water molecules, microwaves are particularly effective at heating them. When these waves are directed at food, the water molecules inside the food absorb the energy and start vibrating more rapidly. This increased vibration transfers energy to nearby molecules through the processes of conduction and convection, and this is how heat spreads throughout the food item. This is also why foods with higher water content tend to heat more quickly and efficiently in a microwave oven compared to drier foods, which do not absorb the waves as readily. Next, we turn our attention to infrared radiation, often abbreviated as IR, which is emitted by all objects that possess thermal energy, or in simpler terms, heat energy. The hotter an object is, the more infrared radiation it will emit, so temperature and infrared output are directly linked. This principle is put to use in various applications, one of which is infrared cameras that allow us to see in complete darkness. These cameras are specially designed to detect infrared radiation and can differentiate between warmer and cooler areas by measuring how much infrared is emitted from different regions. This is particularly useful for identifying warm-blooded animals or people in the dark, as their higher body temperature causes them to emit more infrared radiation, making them appear bright against a cooler, darker background, which emits less infrared. Another everyday use of infrared radiation is in cooking, especially when metal is heated to high temperatures in ovens, grills, and toasters. The hot metal surfaces emit infrared radiation, which transfers heat energy to nearby food items, helping them cook. Unlike microwaves, which penetrate food and heat it from within, infrared radiation primarily affects the surface of the food. This is the reason bread gets crispy and toasted in a toaster rather than simply warming up throughout like it would in a microwave oven. We also use infrared radiation when operating electric heaters. These heaters convert electrical energy into thermal energy by heating up metal components. Once the metal becomes hot enough, it begins to emit infrared radiation, which then spreads out into the surrounding environment, warming up the air and objects in the room and making the space more comfortable during cold weather. It is worth noting that both microwaves and infrared radiation are generally safe in small doses, and the background radiation we receive from natural and artificial sources does not pose any significant risk to human health. However, when these types of radiation are present in high quantities, they can become harmful. For example, if living cells are exposed directly to microwave radiation in a microwave oven, they would absorb the energy and heat up to the point of destruction, effectively boiling and dying. Similarly, if a person places their hand inside a toaster or too close to a hot grill, the infrared radiation would be intense enough to cause burns and destroy skin cells. So while these forms of radiation are incredibly useful in everyday life for cooking, heating, and communication, they must be used with caution and respect for safety guidelines. Anyway, that wraps up everything we needed to cover in this video, so we hope you enjoyed learning about microwaves and infrared radiation and found the information useful and informative. Thanks a lot for watching, and we hope to see you again in the next one.